So, hello everyone, welcome to our Ask Geology, a whole new way to understand our mother earth. So, in this today's 7-minute numerical, we will be discussing about one geochemistry question that is asked in 2021 Gate. This is basically one EH and pH relation. EH pH relation, and all of you know the diagram which shows the EH pH oxidation and reduction condition basically. That is called Purovic's diagram. Okay, that is called Purovic's diagram. So let's see the question. So in this question it is given, in the given reaction Fe plus 2 plus of H2O 3H2O, it will give rise to Fe2O3 plus of 6H plus of 2 electrons. 2E minus means 2 electrons are getting out. So consider ideal condition and take the concentration of Fe plus 2. This is ferrous as 10 to the power minus 5 molar. E0 initial, that is 0.98 V volt. pH is given to be 6. All of you know what is pH. pH is the negative logarithm of H plus concentration. H plus ion concentration, and the value of 2.303 R cross of T divided by F is equal to 0.059, where F is the Faraday constant, and the value of EH on the Fe plus 2 divided by hematite boundary. All of you know this Fe2A3. What is this? This is hematite. Okay, so the value of EH on the Fe plus 2 hematite boundary at 25 degrees centigrade is dash volt. So in this case, first of all, when we are considering EH, this is basically a EH-pH diagram. Okay, this is oxidation reduction condition. This is related to oxidation reduction condition of the or environmental condition. Okay, so in this case, we will have to find out that which side of this reaction is getting oxidized and which one is reduced. Before that, just take at a look that which formula we are going to use. Okay, so it has a very close relationship with the G. Okay, this is free energy. Del Z is equal to del Z0 minus of RT ln K. In this case, it is given this 2.303 RT divided by F. Its value is given to be 0.059. And all of you know in the EH-pH diagram. Okay, this is your EH, this is your pH. All of you know this is 0. Okay, this is EH0, this is the negative side, and this is the positive side. All of you know we have two equations like this, isn't it? So the equation is EH is equal to 0 minus of 0.059 pH. This is actually for the lower boundary. This equation is for the lower boundary. And what will be the for the upper boundary? For the upper boundary, EH is equal to 1.22 minus of 0.059 pH, or someone says that 1.23 minus of 0.059 pH. So I have seen so many of people, so many of students, they just mug up these things. Okay, so you don't remember to mug up these things. Simply remember the equation of a straight line: y is equal to mx plus of c. Okay, this is also a straight line. This is also a straight line, isn't it? So if we see what is the slope here, we have negative slope. Okay, isn't it? We have negative slope. That means m, it will have a negative m. What is the x? X is the pH axis. Y is your EH axis, isn't it? And what is C? C is the intercept. C is the intercept. For this upper part, what is the intercept? This is 1.22 or 1.23. Okay, and here the intercept is 0. Now, if we just want to write down the straight line equation of this upper part, what will be that? Y, in case of y, that is EH, is equal to m, that is the negative. And what is the slope? This is the angle is 0.059. You have to remember these things. Negative slope 0.059. This is the magnitude of the slope, and x is your pH Cos of C, we are writing for the up part. This is 1.22. So what is the value? EH is equal to 1.22 minus of 0.059 pH, or this is 1.23 minus of 0.059 pH. Like that, for this lower boundary, what is EHY is equal to, what is the slope? This is minus of 0.059. This is mx, x is your pH, and what is the intercept? Intercept is 0. So simply for the lower boundary, EH is equal to minus of 0.059 pH. Okay, this much is clear. So you can see in this relation, the del G is equal to del Z0 minus of RT ln K, which is in case of log, that is 2.303 RT log K. And you can see there is a similarity between this free energy condition and the E0, this is the EHPH relation. Okay, so you can see for E, this is del Z, similar equation, E0 del Z0, RT ln K, you can see this is RT ln K. Or in case of, if we consider the logarithm, this is RT log K, 2.303 will be multiplied. Okay, so in this case, what is the value? E0 minus of RT divided by NF ln K. This is basically the equation we will be using to solve this numerical. Okay, first thing, what is our equation? E is equal to E0, this is EH is equal to E0 initially H minus of RT ln K divided by NF. Okay, this is the equation. He has given the value of RT divided by F. The value of RT divided by F, it is given to be 0.059. So our equation here will be EH is equal to E0 minus of 0.059 divided by N ln K, or sorry, this is log K, because this is 0.059, it is actually giving the value of RT log K by F. You can see this is 2.303. 2.303 means that is, it is in logarithmic log, which is having base 10. Okay, log format. So see, what is the equation and what we will be using? The equation we will be using here is equal to EH is equal to E0 minus of 0.059 divided by N log K. Okay, this is the required equation we will be using in this case. And there are some other things I just want to tell you because these are important. This K is the distribution coefficient. Okay, K is the distribution coefficient, and always this K is expressed. Okay, always this K is expressed at reduced species, reduced divided by oxidized. Okay, oxidized species. Okay, so in this case, in this equation, 2Fe plus 2, 3H2O, in this equation, which one is reduced and which one is oxidized? We have to find out. Then only we will be able to put the value for K. Okay, and what is the N? N is the number of electrons transferred. Okay, number of electrons transfer. In this case, you can see what is this? N is your number of electron transfer. You can see N is your number of electron transfer. Okay, number of electron transfer. So in this case, we have to find out which one is reduced, which one is oxidized. Always remember, for oxidation which lose electron. Okay, lose electron, that will be the oxidized species. So simply formula OO, lose, here is O, oxidation O. So when electron is getting loosed, then that species is oxidized. In this case, the right side part, it is losing electron. Losing electron means electron is getting out. So this is basically the oxidized species. Oxidized species, and this is the reduced species. And another case you can find out, this is Fe plus 2, isn't it? Fe plus 2 in the left side, and in this case Fe2O3, this is Fe plus 3, O minus 2, this is Fe plus 3. That implies this Fe plus 2 is getting converted to Fe plus 3. That implies Fe plus 2 is losing one extra electron to form this ferric Fe plus 3. That's why this is reduced and this is oxidized, isn't it? That is getting reduced, the left part, and this is getting oxidized. Simple. Losing electron means oxidation. Now Fe plus 2 3, Fe plus 2 3 is getting converted to Fe plus 3, ferrous to ferric. Okay, it is getting reduced. Okay, so let us just solve these equations. Okay, and this is 2 electrons, so the n is equal to 2 in this case. So Eh is equal to E0 minus of 0.059. Here n is your 2, then this is log k, that is Fe plus 2 square H2O cube divided by, this is Fe2O3, then H plus 6 to the power 6. Okay, no doubt should be here, I think. So this is E0 value. What is the E0 value given? E0 is equal to 0.98. This is 0.98 minus of 0.059 divided by 2. Okay, let it be 0.0592, and this is log. This is Fe2O3 will cancel out, water will cancel out. What is this? Is log Fe plus 2 square divided by H plus power 6. Okay, so this is 0.98 minus 0.059 divided by 2. This is simply log Fe plus 2 square minus of log H plus to the power 6. This much is also fine, no doubt. 0.98 minus of 0.059 by 2. This is 2 log Fe plus 2, because this 2 will go here, and this is 6 log H plus concentration. Okay, this is also fine, no doubt. Now this EH is equal to 0.98 minus 0.059 divided by 2, 2 log Fe plus 2. Fe plus 2, what is the value of Fe plus 2? You can see initial Fe plus 2 was 10 to the power minus 5. So 2 log 10 to the power minus of 5. Okay, minus 6 log H plus concentration, minus of H plus negative logarithmic of H plus concentration is your pH. So in case of minus log H plus concentration, I can take the value of pH, which is 6. And remember, in this case I am taking this negative sign also, because pH is the negative logarithm of H plus concentration. So I am taking the negative here also, so that it will be positive. This is plus, because this log H plus negative log minus log H plus, इसके जगह पे I am taking the pH of value of 6. It is given pH 6. So 6 plus of 6, this is your 36. Okay, let it be. We'll have to calculate 0.98 minus of 0.059 divided by 2. This is 2 log 10 to the power minus of 5. This is minus of 10, because this minus 5 will come here, minus of 10 log 10 plus of 36. Okay, log 10 value 1, so minus 10 plus of 36, this is equal to 0.98 minus of 0.059 divided by 2. This is minus of 10, log 10 value 1 plus of 36. So we are getting 0.98 minus of this value is 0.0295 divided by 2. Okay, minus 10 plus this is 26. So if you calculate the value, this is 0.98 minus of 0.767. So the value is around 0.21, and maybe it is asking a round up to two decimal places. So our answer will be 0.21. This is our answer. Let us see. You can see this is our answer, 0.21. So I wish that this much of clarification is sufficient. Okay. Remember, what is the goal here? I'm just writing down, because this type of questions are more frequently asked in GATE exam. Okay. So losing electron, that means that is oxidized. Okay. Losing electron, one electron will be lost, that will be oxidized. Losing electron is oxidation. Okay, and another thing, this y is equal to EHPH relationship. Okay, so in this case, what is the answer? Answer is 0.21. So I wish this is clarification explanation. So if you are interested to join our group, then these are the contact numbers you can contact, or this is the mail ID. You can simply put a mail to this mail ID, or there will be a link tree that will be provided in the description box. By clicking directly onto the links, you will be directed to all our social media platforms. And save our mother earth, plant more trees, go green. Thank you, and thank you very much.